Hello, everyone. Welcome to this afternoon session of the fourth React Week edition. I'm here with Nikola, and we are going to talk about React animations, some complexity about it, some math about it, and how that works in React. And Nikola will show us what kind of cool things you can do with some tools and frameworks and libraries that are surrounding animation. I hope that you are in the mood for something like that, and that you are that this topic is interesting for you. So without any further ado, I will introduce you to Nikola Milutinovic, who's going to present himself and tell us about a little bit about himself, and then we will wait a few more minutes for everyone to join, since we had some issues with the links, and then start. So Nikola, please take the stage.
Thank you so much. Okay, well, as Marcus said, my name is Nikola, and I've been doing this engineering thing for more than 10 years now, and I've been mostly involved with startups. And therefore, in those kind of environments, you really need to stand out a little bit, especially with user experience and these animations. And being that people usually don't focus on that, this is where I kind of decided that a little bit of my focus is going to go to, right? And currently I'm working as a CTO of Growth Mill. It's a services company, and we deal with startups. That is kind of my alley there. So today, as Marco mentioned, I'm going to be talking about demystifying complexity behind React animations, and specifically focusing on how Disney actually does it, right? There is a fine story behind how these animations work and why we see some things as appealing as opposed to other things that we are like, well, this is kind of animated, but also, nah, right? So that is the topic of this thing, and we will also go through a little bit of coding. I'm not gonna overwhelm you with anything. This is gonna be pretty straightforward. We're gonna go through some examples and also show how, once we extend everything that we're talking today, how when we extend that, add a little bit of math behind it, how we can actually create some pretty cool things and basically decompose end goals into steps in order to create something unique. So I guess we can start. I'm gonna share my screen now. I'm gonna start with the presentation, and feel free to leave messages and in the Q&A section, and I'll be sure to answer them down the road later in this lecture. Okay, so as I said, this is demystifying complexity behind animations in React, and we're going to start by understanding Disney's principles of animation, right? Everything that Disney has been doing for the past, I don't know how many years, is based on making the characters look like they're in real life, but you know they're not, because they're kind of drawn, but that their movement is really close to being in real life. Everything is based on laws of physics. And if you think about it, when you see a character in Disney animation, now that those principles are applied everywhere, but there is no movement that's linear. Everything is kind of arcish, right? There's an arc to every of those movements. If you think about like geometry behind it, there is inertia, there is mass, and there is emphasizing different properties of a single object on a scene to explain where the object is going and where it came from. What is it? Anticipation. And you can always kind of anticipate what's going to happen, but also sometimes they surprise you, right? And these are 12 principles. We're not going to cover all of them. Some of them, it's a really fine line between some of these things, especially like if you think about slow in and slow out, also like timing, that's pretty close, right? But we're going to talk about squash and stretch, right? That is one. We're going to talk about anticipation, slowing in and slowing out, follow through and overlapping action, secondary action, timing, arc, staging, exaggeration, like all of these things that are combined, they create this illusion of something actually happening and something being in a physical world while it's actually not. So I'm going to start with the first one here. That's squash and stretch. This is an example of squash and stretch, as you can see on a right side. And the idea here is that every object has a rubberish, characteristics. And what we need to think about here is that this specific object, when it's stretched, it cannot change volume, right? We have a finite volume, but it can stretch, right? So when we stretch, we need to lower down the, let's say, height and extend the width of the object. And this is what is happening here. Like it is, starting from something that's kind of thick and going to thinner mode, like showing us that it is actually moving. So when you apply force to something, it will change shape. This is the same thing that happens to your face, right? If you press it, like there is a little bit of movement there. So it's kind of stretching, right? That is the first thing of these animations. We're also going to show how this is applied to user experience and animations in React and how these principles apply. So anticipation, that would be the next one. Whenever something is about to happen, we want to emphasize that movement. You can see this box, like you know that it's going to turn. You know that it's going to turn, that there is something happening with it. This is what we want to present as well with things like with things like buttons, right? When you click on a button, or you click on a toggle button, or you click on something, there is first piece is, when you press on it, there is an animation there explaining, like there is an anticipation that something is going to happen. It's leading you into what is about to happen next, right? Slowing in and slowing out. We are using this. I think that everybody here from you guys that are listening to this saw something called easing, right? Ease in and ease out. This is basically that. There is no linear movement in real life. Nothing starts from speed of 20 kilometers per hour. Everything starts from 0 and gradually goes to that speed. Some cars accelerate faster than the others, but the idea is that something cannot start from 20 or 30 or 100 miles or kilometers per hour. It needs to start. So there is that movement, slowing in and slowing out. And if you want to emphasize that, and if you want to actually present something that has physical properties, the movement of that object needs to be obviously slowed in and slowed out as it changes some properties, right? Follow through and overlapping action. You can think about this when you're running, and if you have long hair, when you're running, your hair is behind you, right? But when you stop, because of inertia, your hair is going to go in front of you, right? Everything is like that. If you are, if you have a coat or something, there's a little bit of coat going back. You know about anime, like arms are like this, and there's all of those lines happening in the background. This is because there's inertia, there's some speed happening on one side, and when it stops, whatever object is moving, there is that overlapping action. Something else is happening, and we are also following through to explain that there has been some speed to an object added. We're adding speed to an object of mass, and it has inertia. So when it stops, everything that's obviously attached to that or somehow dragged to that thing, it's going to continue moving and then fall back into place. Secondary action. So secondary action is super interesting because it's used to emphasize that something happened to the primary object. As you can see here, even though we see that this big box is rolling, then it's completely fine. We have this thing of a small box up there that's emphasizing that the other one actually rotated. And it's silly when you look at this from this perspective, but if you look at it from perspective of a button, that when clicked or selected, let's say we have something that can be selected or not, like when you click on it, it changes color. That is secondary action in a form of user experience and user interface. So we are emphasizing one action by providing an animation to another object or a property. And okay, if I'm going too fast, please just send a message in chat or something. But I think this is kind of fine. I want to get to the more interesting pieces. Timing. This is why I said it's super close to easing in and easing out. Here on the right side, it is presented as that, right? So we have this easing in and easing out thing, and the whole animation thing, the principles are considered like it's consisted of, hey, we have a timeline and we have some keyframes. We're gonna talk about that, and timing is super important because if something is slow, that tells one story, but if something is really fast, it tells another story. Or if something is easing into a certain position, it tells different story. And I'm constantly repeating this, telling the story part, because it is important. Because through animation, we want to tell that story. We want to explain to our customers or viewers, users, whatever you want to call them. We want to explain something. We want to emphasize certain things and draw their attention to that. Not to exaggerate that, but we do want to actually have those fine details. And here's a little bit of how that can be implemented and how it can look when implemented in the switch, right? You can see we have stretch, right? We have secondary action right there. We have overlapping action, kind of goes outside of the boundaries of the thing. We have easing in and easing out, and also like timing is also almost perfect because it's not slow, it's not fast. It's just right amount of time taken from the user to show that something happened. So we are kind of using all of that within this simple example. And when you think about it, you didn't even know that there are all of these principles behind an animation. Maybe somebody knew, but most of us don't know that there are a lot of these principles behind these animations. But those are the things that are actually making this happen. In order to make this, we're going to be using Framer Motion. Framer Motion is a library coming from Framer. It's a popular UI UX tool for providing prototypes and designs and whatnot. And a lot of these principles are already built in. And in order to show certain properties, I will be needing to deactivate defaults of Framer, but also I will show you what the defaults are. And defaults are pretty nice to start with. It's super fine, even just by including Framer, your app kind of gets that polished look when it comes to animations. You'll see how that turns out to be. And as I was saying, the key thing is this timeline and keyframes, right? Here in the middle, we have something that we will call timeline, whatever this is. But this is a timeline, and there are some segments here representing obvious segments of time. And what we know is that at the beginning, this is our circle. We want that circle to move to this place at this time, and we want it to end here. If the movement is linear, these grayed out or more transparent are just presenting how this movement is shown over time on your screen. It's pretty linear. There's the same amount of separation between there's gap, the same amount of gap here, and the movement is linear. And again, going back to the initial thing, that is not what you see in nature. But we definitely start from somewhere. So here, as you can see, this is super linear. Movement is shown, and here it will just stop as it hit a roadblock. Literally, there is no show of speed or mass or whatnot. And this, we don't need to apply this principle of linear movement to only position, right? So it is the most easy one to comprehend. Like we're going to move something from one place to another, so we're changing its position on x-axis. But if we see, like we can actually change scale or width or height, whatever, right? So, and again, it's spread out evenly on this timeline, and it goes to the big one and then goes back to the small one. So now we are changing other properties. So we're not changing X position of this particular object. We're gonna be changing scale. But what if we kind of bend the distribution of change a little bit. This is where it comes to the concept of Bayesian curves. It's a mathematical thing. It doesn't, we don't necessarily need to go into details of it, but this is what kind of adds the easing effect to what we are building. Timeline stays the same, but distribution of changes against the object's property, whatever property we're animating, is differently spread out. So it says here, we still need to change it, but we're going to go super slow in changing it. So it's, change, and then as we're moving up, the gap between these is becoming bigger, meaning the time between two changes is, I would say, it is becoming bigger. Therefore, the movement needs to accelerate. So here you can see how this curve actually gives us that easing in and then easing out effect, right? So we're slowly getting to change, and then all of a sudden we are like bam, 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 changing that movement. The same thing can happen with a size, right? Slowly, not a lot of changes, and all of a sudden, like bam, 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 a lot of changes happening in a small amount of time, and therefore, size change, like these deltas between the thing are getting bigger, and therefore the whole movement is faster, right? So, as I said, the most important thing is meaningful animation. All of these principles need to be applied carefully, not to over-exaggerate something. If you're building something for a specific brand, therefore, if you're building something for, let's say, a law office, like lawyer's office, a legal office, actually, you don't want to have that jiggly effect, right? But you want to have certain properties that are going to emphasize their business and seriousness of what they actually do. On the other hand, if you're building for a startup or a game or something, there you want to have all the jiggly things in the world and apply as many of these principles as you can. But again, always according to the brand and according to the image of what you're actually building. And that means tell a meaningful story, tell a story about that. So this is what I'm going to do. Like, we're going to try to tell a story about that switch button through code. So I'm going to expand this a little bit. I'll like here, give me 1 second. We're gonna have some code here, and also we're gonna have some code, like some presentation here. Okay, so this is a simple React app. Nothing special here. The only couple of packages included, obviously, I'm using style components for all the work that I do. You feel free to use whatever. But the important thing is this framer motion thing, right? So here, let's start from a starting point, like obviously. This is what everybody can build. I'm gonna click on this. It changes state, obviously. Just give me 1 second. I'm not sure what is happening. Okay, cool. So it changes state. And this is something that we can definitely build. As you can see here, this is one way of doing that, nothing special. We're tracking whether something is checked or not. And when we click on it, we are basically toggling that. And based on that thing, we're flexing to the end of the start. This can be done in a million different ways. This is just one of them. So it's not that important. So, and obviously there is no movement to this. This is just blinking. There is no animation, and obviously super boring. Let's get to the squash and stretch example. This is going to be an example where I'm actually going to show you what is happening and how we're adding framer. And then, as you can see here on the left, I have something commented out, and I'll show you what small things are doing to the setup that we have here. So this is what we have. This is super linear motion between these two things. What I did is, in comparison to the previous thing, is that I'm going to also show you here. Oh, sorry, started. This was a regular div, and this was also a regular div right there. Here we're using a div from motion library, framer motion, and we're using the div here. This allows our properties to be animated, and our objects, our objects to be animated, and allows us to give them things like transition properties or animate properties, and we're going to talk about that. So what actually is happening here? I still have this check thing. So that's indicating whether we are in what state we are, right? Is this going to be checked or unchecked? And here I'm saying, okay, so if this is checked, move X, like X of my node to 110, and this is to 10. And these are like just plain numbers, calculated based off of the width of this particular switch and the width of a knob. So as you can see, like 200, and we have minus this 80 and minus 10 for padding. So that's 110 here. So and 10 for padding on the left side. So this is what is happening. And I intentionally said here, let's transition from one state to another state using linear movement, just to show how this, even though it's animated, it looks boring. If I remove this is going to go to default of Framer, and we already have easing. So as I said, a lot of these principles are already applied in Framer, and therefore I needed to like literally override that in order to show, to prove my point. But yes, so here we are here. Again, this is super basic, just moving from one place to another. So if we actually want to have that squash and stretch effect, what needs to happen is that this knob here needs to shrink its height, extend its width, because we are, as we said, we cannot change volume if we want to keep the properties. So we are changing that, we are squashing and stretching a little bit to show that off. Let's see how we can do that. Those things are, as you can see here, I have something called knob variance. And based on whatever this, you can name this whatever you want, I call them checked and unchecked. Based on what state I'm in, I'm gonna use certain values, and I'm gonna uncomment this thing here and comment the other one. So this is again the same thing, because I did not literally do anything by saying here animate from 110 to 10. This is exactly what I did here. I said that we have some variance for specific for this knob. I said that initial one is unchecked because my state is, my checked thing is false. And I said, well, whenever this thing changes, animate to an active variant. And this active variant is just memoized thing of checked or unchecked, depending on whether this flag is true or false. There is nothing else to this in order to make this animation. So, but as I said, we do want to change the width and height whenever this thing is this thing is moved. So how are we going to do that? This is our timeline. This is literally our timeline. If you remember from this slide here, this is what we are doing, right? These are the things. In this specific moment, I want some properties. In this specific moment, I want some other properties. So going back to this is what I said. At the beginning, I wanted to be 80 in width. I wanted to be 80 in height. Then I wanted to squash a little bit, right? So I want the width to be bigger. I want height to be smaller. And I wanted to go back to its original state at the end. The same thing goes for the other side. So let's see what happens. It kind of does it, but it's still a little bit off. There's something bad happening to it. And that is just because we are not tying these changes to the timeline of how our X is changed, because this actually goes there and then this timeline gets activated. So if we applied the same principle to our X movement, and now we have the same thing. So we're saying at the beginning, I want this. At 25% of this, I want this size, and 75% I want this size, and then I want position, and then I want to go to this position. So this is what we did. At this point in time, it goes there, and goes back, goes and goes back. Simply by providing and specifying how these properties are placed on our timeline. Okay, that is that as far as squash and stretch goes, and this looks pretty fine. This is okay. Let's move on to the next principle. We have anticipation. So what we want to do there, I'm going to show my code here for anticipation. Now, what we want to say is that whenever this is pressed, we want to say, hey, this thing is going to move. This is going to move. So when we click on it, as you can see, it actually draws your attention. It's like, oh, I actually did something. And then it goes there. Now here, I click on it. It kind of, like a slingshot, right? It's doing something. And then now, when I release it, it goes to the other thing. I did not do anything special with it. This is the power of Framer and Framer motion. There is a property, and I'm sorry I'm formatting this right now. There is a property called while tap. And what I did here is like, okay, when this thing is tapped, so when I apply pressure to it, use one of the variants here based on the active variant. I have my knob tapped variable here, and it's going to use either checked or unchecked. And the only reason I did that because I wanted to move slightly to the left or to the right, depending on where it is. So right now, if I click on it, you'll see that X actually changed a little bit to the right. So it moved to 0, right? So it's kind of like a slingshot. So when I release it, it goes right to the end. And the same thing here, it goes to 120. It's not even 110 anymore. And now when I release it, it goes to this position. So this is while tap, right? And everything else stayed the same. I did not change any of the other properties here, maybe a little bit, but nothing super important. That is the main idea. So this is how we actually create anticipation. So you know that something is going to happen, and you have this fluid, really nice looking motion. I think we already kind of covered the slow in and slow out thing, but let's we can see how it actually goes. What is happening with here. So if we have this particular thing, it's I need to turn on easing here as well, just to make my point. It is the motion of me actually clicking on it and it going here. As you can see, it's pretty linear and it's not natural. Again, this thing comes by default, and there are other easings that we can talk about, and I will show some of them later. But this was literally just a presentation of, hey, if you decide to ruin this animation and add linear movement, this is what you're gonna get, right? Okay, follow through and overlapping action, right? So this is what we want to do. We actually, based on the slides that we talked about, now we want to add something. We want to add that inertia. Say that this knob was actually, imagine it got kicked, right? But it cannot get out of it. There is a net right here. So we're telling a story, right? There's a net here, and this actually goes right into the net. It's popular now. We have World Cup happening. The same thing. The ball goes into the net and comes back. That is what is happening to our thing. And this is not combined with other principles at the moment, just for the showcase of this particular one. But as you can see here, it's literally moving there. How did we do this? One of the basics of Framer is spring, right? So there is a spring tied to every property change. And we have a lot of properties that we can define, not a lot, like four properties we can define for a spring, but you can imagine literally having a spring and you're controlling the physics of that spring in order to show some, to tell a different story, right? So one of those is bounce, right? So this is what I said, like here, my transition, I'm going to define a transition for this particular knob. I said, okay, cool. So my transition is type spring and bounce is 0.5. If I say 1, it's going to be pretty bouncy. And as you can see, it changed a little bit there. And here, dampening, this is like how long the spring will oscillate. over time. If we say 10, it's going to be pretty short. But if we say 1, it should oscillate pretty heavily, right? This is how easy it is to create this ridiculous thing. This is not something that anybody would use, but for the purpose of actually showing how this actually works, this is, something. And you can see there is a little bit of movement on width and height. So it's kind of like a boiled egg. So when you click on it, it starts to jiggle. It tells one story. This can be applied somewhere. So this is how easy it is for you to, everything else is the same, for you to add that spring animation and that spring motion to the whole story. Let's go to the next one. Secondary action. This is kind of interesting. Here we're starting to complete the picture of all of these things. What we did here is now we animated our switch wrapper now. So we said, hey, here are your variants, and using the same principle, we are animating things, and these are your variants. Your checked thing is background blue. Your unchecked thing is background grayish. And I click on that, it changes. This is now indicating that I obviously checked it, and that is our secondary action. In an animation that I just showed before in slides, we also added a little bit of width and height change to our wrapper, and we can actually do that. But again, I'll leave you to it, so you can actually do those things on your own. And if you need any help, please reach out to through any of the channels. I'm everywhere. So that is that. If we go now to the last thing here, it's timing. And why I believe this is super interesting. This is everything combined and a tiny bit more. So here you can see we added a little bit of bounciness. We have some damping, we have some mass, and we also added duration. So also I altered checked and unchecked just a tiny bit, and to show this, it's quick to the end, right? So this is a slingshot. So I'm quickly turning something on, but when I release it, it's going to get that bounciness thing. So this is complete story told about this button. When you click something, it's turned on, but when you release it, you're like, oh, right? You're like, we're sorry that you're turning something. We're actually sorry that you're turning something off. That's the story told behind this button. And you probably think like this guy is obsessed with buttons and the switch buttons, but there is a little bit, to it. When you see something like this in a smaller form factor, you will actually be surprised somebody put effort into this. And you're going to say that, how much effort somebody actually put in this, but it's not that much. It's pretty simple. This is just numbers, nothing special. Your parameters here and there, and a little bit of color, and you can definitely tell that story. If you want to tune that animation down a little bit and be a little bit more professional, this is how we would probably do it. This is something more standard that you can see, across the internet. And again, solid animation. It does lack our secondary action there. We can obviously add that, not a big deal. And we can actually show how that is being done. So let me click here. As you can see, literally I'm going to copy and paste this into here. So those are the variants, and here I'm going to say, well, my variants are these from our switch wrapper. I'm going to add them here. Well, other way around, but you get the point, right? So again, this is how easy it is. Oh, actually, maybe I just need to, yeah. Oh, interesting. Well, you get the point. So the whole thing is super easy to add these interesting animations to your app. If you really want to go crazy with these things, you can do something like this. Imagine having poker I'm talking about planning poker for agile development, and a bunch of people are joining, and you want to actually create some sort of animation. Whenever somebody joins, you want to actually extend the table a little bit. This is not hard. This thing is just a div with a border, and it based on number of people, it changes width and height, right? Whenever you click on, and then chairs around distribute differently. There's a little bit of math behind that, how these chairs are distributed, but the motion is simple. You can even see that this thing when it's right there. So what we animated is its movement from this position to this position, easing, adding a little bit of bounce, and it just grows, as you can see. This is super easy to do with tiny bit of animation. The hard part about this is actually calculating how many people should sit on each side. That would be the harder piece of this animation, and that is also not complicated. As you can, I just want to emphasize one thing. Even though it's a bug, it kind of explains how this works. So now when I release, one of these is gonna show. Like right here, you can see that it's right there until the animation ended. So this is what we're doing. We're animating it there. We're rotating while we are animating and moving it along X or Y axis, depending on which chair we are talking about, right? And this can be a starting point for a nice app. The other thing I want to talk about and show what kind of animations we can do is, let's say this transition right here. This is a simple transition. Even though it looks complicated, if we dissect what is actually built here, we have one circle right here. We are changing its perspective. So we are changing that property over time until it gets in the middle. So give me 1 second. So we are animating until it gets here in the middle of this screen, right? And we're changing that its perspective. So it's gonna expand. At that point, we're switching, and because I'm just sharing right now and all of these things that are happening, there's a little bit of lag. So you'll see here that when I click on it, right there, it switched. So the background became the other color, and my expanding circle became the other color. So this is what we get. We have this sort of animation. I did not think of this animation. This is something that I saw on TikTok and then decided to build it. But and as you can see here, it's super easy. And when you dissect what is happening, it's not that complicated. The only thing that you're doing is literally expanding a circle until it gets to a certain point, changing its color, and then flipping it and shrinking it down. So that's that. Okie dokie. So let's show another animation. So here, this is all built with Framer, by the way. We have this thing. This is super simple. There's a little bit of physics here. That's simulated physics. A little bit of sinuses and cosinuses here in order to calculate where this bulb should be when I actually drag it. That might be complex-ish, not, but still a couple lines of code there. But here's what is interesting. When I pull it down, it kind of turns on. And now you have all of this text behind, right? And this is an animation. Again, I did not think of this. I also saw this on TikTok. So how is this done? There is a text that's black, literally on black, black on black. I'm gonna show you. So here somewhere here's my text, right? It's black on black, and all of this text. I'm not sure. I can even show, well, you can see that it says light my fire, light my pot. Sorry. So that's there. And what am I actually doing here? I'm literally, when I do this, I add an SVG file. I add a picture that's dragged along between my bulb and my text. So text basically gets background, right? And this is how you get this effect. It looks interesting, it looks complicated, but at the end, it's super simple. No mystery, no magic behind how these things are being done. And this is, a couple lines of of code to actually do that, and a lot of lines of code to actually simulate the bulb moving left and right. And this, when you release it, it kind of, does this thing like, dingling. But if you, eliminate that, there's a pretty cool effect. Probably useless for majority of things, but really cool show off. And also shows that, animations and interactions do not need to be complicated. And then if you really want to go crazy with algorithms and actually, do some SVG drawings and things, it can look something like that, like this, right? We can do, this is maze generation algorithm based on graphs. And I don't want to, go into that, but this is, this can be also done with a little bit of math behind it. As you go into more and more complex animations and generations, more math will be necessary in order to do these things, and a little bit of algorithms here and there. But this is where, for this, you don't need anything. For any of these things, you don't need any math, right? There is no reason why we shouldn't be, adding these interactions to our apps and make them pop every day, right? So that is all as far as I have like maybe a couple more minutes before we jump into Q&A, but that is all. But we can go into Q&A. I finished a little bit short, but that's about it. We can go back to something if somebody wants to talk about something a little bit further.
Thank you, Nikola. It was really interesting. I knew about frame of motion, but every time I was like too lazy to sit and read the documentation and find out like why this is array and why this is like this. So I think that you, I posted in the chat, like it was like mind blowing for me. Like when I discovered, this is the timeline, these are the keyframes. So it should not be that complicated. So I have one question until the others. Guys, feel free to ask questions in Q&A. I'm pretty interested in this topic, so I will fire up a few questions that I have prepared. So what happens with, for example, that maze that you showed, animation? Does this works like when, for example, you change the aspect ratio or it's not like zoom in, zoom out and stuff like that? Is it connected to something like that because you're adding some X and Y's, or it's completely kind of scoped and
this ends up being an SVG, right? So this is SVG generation. So you can do whatever you want to do with this specific SVG file, right? And at this point, you can control that however you like. At this particular example that I posted on my website, it's not doing anything if you shrink it. This is why it's small. So it kind of, I was not making that responsive, but just adding a few properties to SVG is gonna add that desired effect if you like. But at the end, this becomes an SVG file or an SVG component, right?
So yeah, so it will not have any effect. Like if I zoom in browser or something like that, probably it will work as well as expected, right?
Yeah. Oh yeah. That should not be a problem. Yeah.
Oh, nice. Okay, and what about yeah? So we are applying these actions for kind of elements, and we want like manys and everything. So does these actions are actually can be just regular components like wrapped in our click listeners and everything, or can we attach some events to each of that, right?
So we are talking about this, right? Like these things.
Or the maze, for example, I want to click on the maze and to draw me like exact the path or something like that.
Oh, I understand. Yes. So at this point, this is just a regular component. Again, you can I can even pull up the code for this if necessary, but you can definitely attach click listeners to this, or it is behaving like a regular component of React. You even have ref for it if you want to do some implicit control, and the same way you actually generated the maze during the same time you actually generated a path through it. So you would be able to draw a line that goes through that. That would be an interesting exercise when you click on a maze. And interestingly, like whenever you refresh, it's going to generate another one, right? That's the point of that. So yes, you can, maybe even click and restart the generation process or whatnot. This is a regular component. Any of these are regular components.
Nice. So in terms of, for example, if I want a world map and I want like countries appearing, zooming out, can I do something like that on the framer motion, or do I need something more complex? Like just it's a bit wide question, but like for example, like the for I don't know, like COVID-19, and I want to zoom in, like how the growth, the hot spots and points, something like that. All of that can be done, right?
Yeah,
With animation,
that
with
thing is,
frame
of
motion.
course, yeah. When you said like world generation, I immediately thought of like D&D maps, and like you want to generate D&D maps, and then like can do some interaction there. Yeah, you can definitely do that as well. But the thing is, here's the interesting thing: SVG, as it is, like as we know it, we can. This is not going to do anything right now, but let me just show you one thing. So if we had an SVG here, and inside we had a G or whatever we have there, right? Any of these things can become framer motion components. If I do motion.svg, it automatically gets all the things like variants, animate and whatnot, right? Transitions and all of that stuff. The same thing goes for this, like motion.g, and this is the same thing. And now you can control it like I controlled my knob here. You can control any of that, tap, hover, whatnot. So that is the beauty of Framer.
Oh, gotcha. So basically, the native SVG tags are actually also available in Framer motions as motion tags, right?
That is correct.
And then they have their own controls that can be like changed to achieve the animation effect, right?
Exactly. Like everything applies. The interface is the same for any of the motion components. And as you saw, there is an SVG, there is G, there is path, there is rectangle, all those fine stuff from SVG directly.
Okay, nice. So one more question regarding the performance. So let's first go back. I was lazy and not reading the documentation, but you really well explained it. So I know I'm familiar with what's happening there. And I think the harder part in the animation is actually to figure out the story, or to get the story from the designers, actually, that they give you, I don't know, some animations in something, and then that you make them like actually in the code, right? So that's one thing. And the other thing that I'm kind of concerned and did my homework, right? So about the performance, is this because you showed here, like for the switch button, these are kind of micro expressions and micro interactions, right? So they will not have a huge impact on performance, since it's mostly SVGs in the background, right? Not too much re-renders and stuff like that.
No, there should not be any re-renders for anything outside. It happens like re-renders for Framer are happening only for the components that are being obviously affected, and only in specific scenarios. I didn't want to get into this. There are tags for that as well. We can obviously expand on that topic a little bit more. But the idea behind that is that Framer is working on optimization not to affect the rendering as we are using that. If you go crazy with animations, you will see a little bit of lag. That's definitely. But if you actually have the whole page animated and interactive, Framer might not be the choice for you. You want to go down the path of Theater.js, and that is also interesting. Theater, okay, Theater.js. That's a little bit more like we would see in 3D Max, kind of experience, and actually Maya, 3D Max, or After Effects. So this is where you can get really crazy with 3D models and whatnot if you really want to do a lot of those. Framer, as it is, can do amazing things. Don't overdo it. Don't make you'll see in Framer's documentation, even if we go down the path of 3D within Framer, there is a nice example here with 3D stuff that's also interestingly performant. Okay, and let me see right here. Like here is a switch that we implemented just in 3D. Yep.
And not that you will need this something
Yeah,
for
exactly.
some
Completely useless,
e-commerce,
but also cool. Yeah, completely useless. But then we have this, right? So
yeah.
we have a question in Q&A here. How determine the right array values for X and Y fields to toggle for toggle animation? Is it the trial and error approach or? Okay, cool. This is actually a pretty good question. Thank you so much, Vladimir, for asking this. So let me go here to, I'm going to go to this one, right? So as you can see here in the beginning, the 110 is something that we calculated from 200 here minus 80 here that gets us to 120 and minus 10 for padding purposes that leads us to these 110, right? And this is the position of that we use right here. You have 10 pixels here, you have 80 here, and 110 here. That's the idea. Did I answer your question? I guess I did. If you need a little bit more explanation, sometimes you want to tune these down, like because you might want to go through trial and error, but this was pretty straightforward because basic math here between the width of this and this thing here.
Yeah, I also think if like designers are not satisfied or the client is not satisfied with that effect, you will go to through the path of trial and error and try
That's
to please
exactly.
the client.
Yeah, exactly. And to your comment, Michael, about like designers actually giving us these designs and all of that. Sometimes designers will actually create this. It depends on what they actually deliver to you. Sometimes you have a Figma file, and Figma is kind of limited when it comes to animations. It can do things, but sometimes you don't have that, right? So designer will come and say, hey, I need this to be animated somehow. And then if you have these suggestions, it will spark their animation, right? Their imagination, sorry. It will spark their imagination. So you can be prepared to actually offer more when it comes to this development. So that is kind of interesting. And always pushing the boundaries a little bit. And yeah.
There is one more question related to view transitions, API in the chat. So the question is, did you try the view transitions API? And there is a link, so maybe you can take a look at the chat. And
yeah, I did not try this. And we can talk about this. This is actually super interesting. This is something we've seen. I did not actually try this out. This is what we've seen in a shared layout for React Native, for example. This is something that you'll see there. This came from Android, back in the days. Android had that natively. And interestingly enough, this is pretty bad animation, right? So when you go back and forth between this, there's a linear motion that does not appeal to you. So again, I did not. I guess I answered the question that I did not try this, but then on the other hand, I wanted to kind of comment on this because it looks interesting. So I'll definitely make sure to test this out. And thank you for the remarks.
So yeah, I have one more question. So do you have some opinion about Lottie? I don't know if you know what's the Lottie framework. Yeah.
Lottie is amazing, especially if you have designers that will do this in After Effects and export that as Lottie animation. Adding those things is easy peasy. So I'm a big fan of Lottie. I obviously did not want to show any of that off because it's not developer work, it's more of a designer work and you're just importing that, but it is kind of cool. And it also ties right into the Theater.js story because it kind of works the same way. Lottie will give you a Lottie file that you can import, and Theater.js will actually through this UI here that you can turn on and off. This is an editor this will also generate something called theater file that you can just plug in into your React app, and it works. This works with obviously with 3JS and React 3 Fiber and all of those fine things. But yes, that's same principles. I really like Lottie.
Okay, thank you for the explanations. I think that presentation was amazing.
Thank you.
I was kind of really mind blown because I really I did not have time, being lazy a bit, to read the documentation and was figuring out what's this X and Y and why it's working like this way. But now it's super clear, and I will try to add some animations to my project as well.
It's easy. We should definitely start doing that.
Yeah. Once again, thank you for joining us. It was a pleasure having you. Guys, feel free to fill up the survey for Nicola's presentation. Survey is anonymous, so feel free to, don't be afraid. We are also always open for the critique and also for praise. So don't be shy and leave us a comment. Let us know what was good, what was bad, so that we can improve and provide a better content next time when we see each other. So, okay, this is, I think, for this session. We will see in half an hour talking about monorepo at scale from Alexander, who's working at Adidas. And it's also super interesting talk with new tools surrounding monorepo ecosystem. Once again, Nikola, thank you. Have a nice day, evening. I don't know what it is. It's bright here. But talk to you soon, and we will see each other.
Thank you so much for having me. See you all. Bye-bye.
Bye-bye.